Welcome to this lecture on integer linear programming. So this lecture is going to be an introduction of the topics that we will be covering under integer linear programming this week. All right, so what is integer linear programming? So far we have been studying the linear programming problem, which is maximize a linear function c1x1 plus c2x2 to cn xn subject to linear inequality constraints. Okay, now as we mentioned in the very first week, we study integer linear programming, which adds these extra integrality constraints that say x1 through xn are integers. Okay, and if these are integers, as we mentioned in the very first week, the nature of the problem completely changes. And this week and part of next week is also going to be devoted into understanding what is the nature of this change. And to briefly visualize the nature of this change, originally we were studying the feasible region, which was just a polyhedron. It was a set of points which was bounded by these half spaces, and the half spaces themselves were defined by these constraints. And now in integer linear programming, we are interested in integer points or the lattice points. Okay, and the resulting polyhedron is called a Z polyhedron, Z standing for integers, and we are only interested in the black dots inside the polyhedron and not in the entire green region, and that causes a lot of significant differences, and we are going to study these differences. Excellent. So what is on the menu upcoming this week and part of next week? So the first thing on the menu is we are going to study a relaxation and something called the LP relaxation. Okay, and this is a very important concept. So, and it's a very simple concept. What an LP relaxation does is it takes an integer linear program and temporarily forgets the fact that the variables are integers. So then we study what happens. And different integer linear programming problems will have different things that will happen to them when we drop the integrality constraint. Okay, so that is called the LP relaxation, and we are going to study this. Okay, we are going to briefly touch upon this notion called an integrality gap, which talks about how does the best answer to the LP relaxation compare to the original ILP's answer. And we are going to study some interesting tidbits here, and we are going to look at how this leads to some approximation algorithms, even though approximation algorithms is not the main topic of this class. Okay, and related to this, we will talk about the complexity of integer linear programming. We will mention that it's NP complete, and we will look at some special cases of ILPs that arise due to problems like SAT, vertex cover, for which we will look at an approximation algorithm. Okay, and then stepping back, what we will then look at is algorithms that are based on the LP relaxation, branch and bound algorithm, Gomery-Schwartz cuts, and then we'll try and combine this and see how these can be combined into a branch and cut, which combines branch and bound and cuts. Okay, so that's going to be the agenda for the coming week and a half. Okay, and hopefully you will find this interesting and exciting, as we have found it interesting and exciting teaching and coming up with this material. All right, so stay on for the next video where we will start to introduce the LP relaxation. See you then. Bye.